Welcome to today's webinar, AWS Services Overview. Our presenter today is Jeff Barr, Director for AWS Evangelism. Jeff has been working in the software industry since 1976 when he started working part-time at a computer store while still in high school. Since then, he has worked at a variety of large and small organizations, served as VP of Engineering for a startup, worked at Microsoft, and on his own. As the Chief Evangelist for Amazon Web Services, he tells the AWS story to audiences all over the world. He talks, he blogs, he records videos, and he spreads the word via social media. He's a strong believer in continuing education and recently earned his master's degree in communication and digital media from the University of Washington. Today with us, we also have Len Henry, Senior Solutions Architect, Ben Snively, Senior Solutions Architect, Leo, Principal Solutions Architect, Milty Brizan, Solutions Architect, and Olivia Schoen, Senior Product Marketing Manager. They will serve as our webinar moderators and will be engaging with you and answering your questions throughout the presentation while our presenter presents. Jeff, welcome. The floor is now yours.
Welcome, and thank you all for attending today. We're going to be touching on a few highlights for each of the services that we talk about. If any of these spark your interest, I encourage you to go and look at the product page for that particular service so that you can learn more about what it is, how to use it, and how it is priced. During this webinar, I'm going to present several polls to get a better sense for who you are, what you'd like to do with AWS. Time is going to be super tight, so rapid responses are definitely appreciated. So as I said, this is an overview webinar, and AWS has a huge set of services, too many for us to cover in depth today. So instead, I'd like you to walk away knowing the names and the purposes of the services and to be ready to learn more either online or in one of our follow-up webinars. You can find technical details, programming docs, pricing, and so forth online. One thing to be aware of, I'm going to sometimes mention a service before I have a chance to fully define it. This is because AWS is a layered system and certain parts of AWS depend on and build on other parts. So fasten your seatbelt and hang on for the ride. We have a long history of customer-driven innovation at AWS. We listen, we learn, and we launch new services and features almost every day. As an example, we launched 15 brand new services in 2015. The pace quickens year after year. We've launched 313 new features and services so far in 2016. Here's what we like to call a architecture diagram of AWS. Starting from the bottom up, building on our infrastructure, we have a set of core services for compute, storage, content distribution, databases, and networking. Layering on top of that, you'll find security and compliance. Going up the stack, analytics, application services, mobile services, deployment, operations, Internet of Things, enterprise apps, and gaming. Spanning the top, you'll see the AWS Marketplace, where you can find and buy apps, and then below that, you'll find a variety of different support and training options. Over on the left, you'll see services that support hybrid architectures. Let's start with compute power. There are 5 principal compute services in AWS. EC2 is an important foundational service, and many other AWS services, as you'll see, are built on top of EC2. You can create virtual machines that we call instances that run either Windows or Linux. You get root or administrator control, and you can install any software that you'd like. Instances start quickly and can be turned off when no longer needed. You can scale out and add more instances or scale in less instances very easily. EC2 gives you a variety of instance types with different amounts of memory, CPU power, networking, and special features such as GPUs. We also offer flexible payment options. You can pay as you go. You can purchase reserved instances for a discount, or you can bid on spot instances for up to 90% off. Autoscaling is an important part of EC2. So driven by metrics, and this uses something called CloudWatch that I'll talk about soon, you can set up rules to scale out and scale in as needed. You can use autoscaling to build self-healing infrastructure that replaces instances in the event that an application crashes, or that maintain a certain number of running healthy instances. Lambda is one of our newer services, and the programming model that it uses has come to be called serverless computing. This is actually a really important concept and something you should definitely pay attention to. Lambda lets you have code that runs in response to events or triggers. Your code starts running within milliseconds, so you can react quickly to these events. The events can come from S3 uploads, DynamoDB updates, Kinesis streams, or API gateway requests. And you pay only for the time that your code, and that code can be JavaScript, Java, or Python, is running. Container computing is another new and important technology. The EC2 container service gives you the ability to manage and deploy Docker containers on EC2 instances. It provides you with some tools that you can use to schedule and manage your containers at any scale. You can use this to run entire clusters of microservices without having to install, operate, or scale infrastructure. You can also use other AWS services such as Elastic Load Balancing for traffic routing and EBS for network storage in conjunction with the container service. Elastic Beanstalk helps you to quickly deploy and manage applications in AWS. It supports Java, .NET, Ruby, Python, Docker, and PHP web apps, designed to be easy to begin and impossible to outgrow. Elastic Beanstalk handles instance provisioning, capacity management, auto-scaling, health checks, and load balancing for you. After the resources are deployed, you retain full control over the environment and the resources. Quick poll question. Which compute service would you like to try next? Let's wait a few seconds for these answers to come on in. You can go ahead and enter your replies. Okay, replies are coming in, and looking like we have quite a few people would like to take a look at EC2 and Lambda. We'll put those on the screen for you. So just about even, we've got EC2 and Lambda, with then Container Service and Beanstalk tied for second place. Okay, moving right ahead. Let's talk about storage. There are 6 services in the storage category. S3 is a scalable object store, and you can use this to store any number of objects, each of which can be up to 5 terabytes in size, and you pay only for what you use. You get full control over access to those objects, and by default, the objects are fully private. You can encrypt your objects either using your own keys or keys managed by AWS. S3 is architected for 4 nines of availability and 11 nines of durability. Pricing starts at 3 cents per gigabyte per month, and with S3 and all the other services, you can find complete pricing details on the AWS website. Glacier gives you low-cost archive storage with the same 11 nines of durability provided by S3 at a price level of 1 penny per gigabyte per month. Our customers use Glacier to replace tape backup and for scientific data storage, also for archiving and compliance. Data retrieval with Glacier occurs within 3 to 5 hours. You can integrate S3 and Glacier using something called lifecycle rules that will automatically migrate older data from S3 to Glacier. Elastic Block Store, which we call EBS for short, lets you create block storage devices that can be attached to EC2 instances. The volumes you can create can be up to 16 terabytes in size and can be on magnetic or SSD storage. You can encrypt your volumes by simply checking a box and selecting a key. From there, you can create and use normal Linux and Windows file systems on the volumes. You can create snapshots of the volumes, and you can move volumes from instance to instance. With EBS, you pay for the storage that you provision. The storage gateway integrates your on-premises IT environment with cloud storage. To do this, you install a virtual machine in your data center. This virtual machine presents iSCSI devices to your environment and sends the data to AWS. When you configure storage gateway, you can mix which of your data stays on premises and which is stored in AWS. You have 3 options. You have cached local storage, you have regular snapshots to AWS, and you have a virtual tape library model. We also give you several options to help get a lot of data into or out of AWS. Our customers use this for data center shutdowns, for archive migration, disaster recovery, or offsite storage. One thing you do is you can use a dedicated network connection over a VPN to transfer data from your office, your data center, or your colo facility to ours. If that's not sufficient, you can place your data on a hard drive and send it to AWS and have it show up in an S3 bucket or as an EBS volume. If you have massive data sets or archives that you need to be transferred to the cloud, you can use the AWS Snowball appliance to securely transfer petabytes in physical form. If you have streaming data, you can capture that on the fly and upload that to AWS at massive scale using the Amazon Kinesis Firehose service. CloudFront is our global content delivery network, currently 52 edge locations around the world, and it distributes content based on proximity of the user requesting the content. This gives you higher transfer speeds and lower latency, and is great for static and dynamic content, including videos, images, and web pages. There's no minimum usage commitment with CloudFront. Our next poll question: which storage service would you like to try next? Let's see those answers come on in. I'll go ahead and share those results with you. Looks like we've got S3 taking the lead with Glacier coming in second. And then Storage Gateway and EBS. All right, thanks for being so attentive to the polls. Really appreciate getting this quick feedback. Let's go from file and object storage to database storage. Once again, we offer a wide variety of options. RDS, the Relational Database Service, gives you managed relational databases. It currently supports Oracle, MySQL, SQL Server, Postgres, MariaDB, and Aurora. I'll have a little bit more to say about Amazon Aurora in a bit. I like RDS because it handles all the busy work of running a database. The backups, the patches, the replication, recovery, monitoring, management, and scaling. All those things are taken care of for you. You get to focus on your applications and on your data. DynamoDB is a NoSQL database designed for massive scale. It's fully managed. That means you don't have to worry about availability or durability that you usually have to think about when you have your own NoSQL database installation. Regardless of the size of your database, DynamoDB is going to give you predictable millisecond level performance. It's backed by solid-state drives that give you quick access both for reading and for writing. You scale DynamoDB up and down by simply changing the amount of throughput that you need. Like many services, you can start small and then scale up to whatever you need. Our customers love DynamoDB for applications that need very, very high throughput at the reads and or write models. Amazon Aurora is our MySQL compatible enterprise database. Aurora can scale up to 64 terabytes with no pre-allocation, and it can give you up to 5 times the performance of MySQL. Again, designed to be highly available and durable, giving you 99.99% availability. It does this by making 6 copies of your data across 3 separate AWS availability zones, all backed up continuously to S3. You can further scale read capacity by creating up to 15 read replicas. Many application architectures benefit from an in-memory cache. Elasticache is our managed caching service, supports both Memcached and Redis products. In general, caching improves the performance of your web applications by letting you retrieve information from a fast, managed in-memory cache instead of from a disk-based database. Elasticache plugs into CloudWatch and SNS. You can set up and start using a cache in a matter of minutes. Amazon Redshift is a fast, fully managed petabyte scale data warehouse. Net operating cost is generally going to run about $1,000 per terabyte per year. We give you both ODBC and JDBC compliant drivers so that you can plug in your existing business intelligence tools and query the data in your Redshift cluster. You can resize these clusters up and down as needed so that you can support whatever size workload that you have. And it integrates really nicely with S3 for both data loads and backups, so you get to take advantage of that availability and durability of S3 that I mentioned previously. For our next poll question, give me a sense of which database service you would like to try next. All right, and the answers are starting to come in. Looks like we've got RDS in the lead, a little bit ahead of DynamoDB, but not by much. You can see those answers on the screen. Excellent. This is super helpful. Really appreciate you taking the time to respond to our polls here. Let's move ahead from databases to networking. 4 services I'd like to tell you about today. The first one is called the Virtual Private Cloud, or VPC for short. VPC lets you provision a private, isolated section of the AWS cloud. When you do this, you can then launch AWS resources in a virtual network that you define with IP address ranges, subnets, and so forth. You get to define a virtual network topology that resembles a traditional network that you might run in your own data center. Within this virtual network, you have complete control of the environment. You can select your IP address range, you make subnets, you can set route tables, you can put access control lists and security groups on the subnets, and you can control the traffic that comes in and out of the VPC and in and out of each of the subnets. And really importantly, you can link VPC to your existing data centers across a VPN, and you can peer multiple VPCs together to create complex multi-network architectures as well. Route 53 is a highly available and scalable domain name system, often known as DNS, as a service. So one important aspect of Route 53 is that it helps you to support a bunch of different routing policies. You can do weighting, you can do latency-based, you can do a failover model. And Route 53 also supports something called geolocation, which means that it can route traffic to the closest endpoint. You can also use Route 53 to both buy and register brand new domain names. An important part of a scalable application is elastic load balancing, or ELB. ELB automatically distributes application traffic across multiple EC2 instances, and it also monitors instance health. This lets you actually build applications that have a greater degree of fault tolerance. ELB plugs into another service, autoscaling, so that when you're autoscaling up, the instances that are created during that scale-out operation will get traffic, and then instances that are terminated during a scale-in will not receive traffic. So EC2 plus ELB plus autoscaling all fit together nicely to let you build scalable applications. Direct Connect lets you have a dedicated, consistent network connection into an AWS region. To do this, you work with one of our Direct Connect partners. These partners have co-location facilities that connect directly to the AWS region of your choice. And what this lets you do is, as you work through this partner, you end up with a high-speed connection between your data center or your corporate office and then the Direct Connect co-location facility, speed ranging from 50 megabits up to 10 gigabits per second per port, lets you get that dedicated connection to AWS. We also have a very wide variety of application-level services. The Amazon Simple Email Service, or SES, is a scalable, cost-effective email sending service. You can use this both for bulk and for transactional emails, designed to support both businesses and developers. Kind of interesting fact, SES evolved from the systems that we use internally here to send email to Amazon customers all over the world. With SES, you get visibility into successful deliveries, bounces, delivery failures, and spam complaints. SES focuses on delivery and deliverability, and deliverability is basically a measure of what is the probability of a successful delivery of the message to the final recipient. Cloud Search is a managed search service. To use Cloud Search, you create a search domain, you upload your documents, which can be either JSON or XML style, and they'll be searchable within just a couple of seconds. Cloud Search supports 33 separate languages. It gives you some higher level search services, things like highlighting, autocomplete, and a geospatial search. The Simple Notification Service, or SNS, is a web service that lets you set up, run, and send notifications from the cloud. You use this by creating a topic and then publishing messages to it. The messages that you publish are delivered immediately to subscribers and to other applications using a variety of different delivery methods. The methods include mobile push, HTTPS, email, and you can also arrange to call a Lambda function. A number of AWS customers are doing various kinds of media processing and presentation and make use of Elastic Transcoder. So this is a scalable managed media transcoder. What it does is it transcodes files into the format that you need to play back on smartphones, on tablets, on PCs, and so forth. You can use Elastic Transcoder in conjunction with other services to create a complete streaming video pipeline. Generally, you would route S3 to Elastic Transcoder, route that to S3, and then make all of that content available via CloudFront, and from there to your customers. This is a managed service, so it allows you to transcode your file into the format you need, and then comes back in ready for use on a wide variety of different devices and rates. The Simple Queue service is a message queuing service, and this is, once again, highly scalable, hosted queue, designed to be used to store messages that travel between computers or different parts of a distributed system. Many different types of AWS architectures make use of SQS as a fundamental messaging component. You can think of SQS as a bridge that connects different parts of your application together, and where you can basically route work requests from place to place with the Simple Queue service. At a level up from SQS, where you need to do a bit more coordination, we have the Simple Workflow service. The Workflow service coordinates either synchronous or asynchronous tasks, which are logical application steps within your application, manages the state, the decisions, executes the tasks, takes care of logging. Designed so you can design the workflow, it'll take care of the execution, run your tasks reliably and in order. So you focus on your application instead of on the workflow infrastructure. The API Gateway helps you to package, deploy, and manage your APIs. And these APIs can either be running in the AWS cloud, they could be on either EC2 or in Lambda, or the API endpoints could be in your own data centers. You get things like version control for your APIs, and once again, it is a fully managed service. Next poll question. Let me know which application you'd like to try next. Application service you'd like to try next. All right, answers coming right in here. Looks like the API Gateway is quite popular today, followed up by email, and looks like tied for simple queuing and simple notification. More seconds there. All right, quite impressive. Looks like a lot of potential use for API Gateway. Excellent. Thanks for all that info. That's really helpful. Let's move on to administration and security. These services tend to be Super important once you go from individual usage of AWS to the point where you say, I really like what I see, I'd like to start making widespread use across my organization or my enterprise. Always good to think about these kinds of things up front, and even when you're in the initial stages of app design and app building, think ahead a little bit and think how you're going to scale up to the enterprise and what kinds of things you might need to do with multiple accounts, roles, and so forth. All of these different administration and security services are there to help you with those aspects of apps. The directory service is a managed directory service that's compatible with Active Directory. So you get all the features of a directory that's running in the AWS cloud, but it's once again, it's a managed service, so you don't have to worry about infrastructure, availability, or scalability. When you're running the directory service in the cloud, you can join your Windows EC2 instances to a domain in the directory. And so then you can actually get to the instances using the domain administrator credentials from the directory. Identity and Access Management, or IAM, really a key fundamental service where you use this to, at a very fine-grained level, control access to the different AWS services and resources that your users would like to use. When you use IAM, you create and manage users, and you then grant access to the resources to those users. You can federate between your corporate directory and AWS, so you can use existing corporate identities to allow access to AWS resources, including S3 buckets, and you can do that without having to create a new identity for those users. The Trusted Advisor is an auditing tool that checks your account against a set of AWS best practices. When you run the Trusted Advisor, it analyzes your resources and then gives you a report that gives you very specific guidance and advice about what to do. This advice is currently focused around 3 distinct areas: cost optimization to help you get the most out of what you're running, performance to identify situations where you might not be making optimal use of AWS, and then fault tolerance, where maybe there's situations where you're not positioned to handle faults in the infrastructure. Trusted Advisor is set up so that the basic checks are free, and then if you're using business level support, then you get access to all of the checks. As you start to use more and more of AWS, you're going to want to be able to track user activity and changes to your AWS resources. This is the province of CloudTrail. You can use CloudTrail to take a detailed look at the API calls that are made against your AWS resources. The information that's recorded includes the identity of the caller, the time of the API call, the source IP address of the caller, the parameters of the request, and the response elements that were returned by the AWS service. So CloudTrail gives you this very detailed look at who's doing what to which resources. As you set up this infrastructure, you're going to want to monitor it, and for that you will use CloudWatch. This is monitoring service for cloud resources and the applications that you run on AWS. It monitors existing AWS resources, things like EC2 instances and RDS database instances. And you can also use it to monitor custom metrics and logs generated by your application and your service. You can then set alerts and alarms and alarm thresholds that can use to trigger various notifications. You can use it to trigger auto-scaling. And so you use all this, you get visibility into your resource utilization, your application performance, and the overall operational health of your systems. AWS Config takes an inventory of your AWS infrastructure. It reports on that inventory, and then gives you notices every time a change, when something is either new or changed or deleted within that infrastructure. You can use this to get a history of what a resource looked like at a particular point in time. So you can actually roll back the clock and take a look and say, what did my configuration look like at a particular point? Great for operational support. You can use this to understand the possible impact of a change in infrastructure. Great example, let's say you're looking to change a particular security group, you can use AWS Config to see what resources are using that security group and then understand the impact of the change and also figure out who you need to tell about that change. As your organization grows, you're probably going to want to share applications within your users and exercise some level of approval and control. To do that, you'll use the AWS Service Catalog. This service helps you create a set of catalog of IT services that you've approved for use on AWS. You can choose the kinds of items that you'd like to include in the catalog, the virtual machine images, the servers, the software, the databases, and even the multi-tier application architectures. This is great when you need to start ensuring that your internal users are following whatever corporate standards you set up. So you can control at the individual, group, department, or cost center level which services they have access to and how they get to use it. You get to define products that are composed of AWS resources, EC2 instances, storage, databases, and so forth. And then the next step is you create a portfolio. And this portfolio is a collection of products where you manage who can use them and publish all of that to your service catalog. Some of our more advanced customers run workloads that require them to use what's called an HSM, a hardware security module, to protect the access keys that are used for their applications. The AWS Cloud HSM is the access to that hardware security module that runs in the AWS Cloud and allows you to keep that same level of security that you would do if you had that same device in your own data center. You get complete control of all the keys and of the cryptographic operations performed by the device. You even have the option to sync the Cloud HSM with an on-premises HSM and using the Cloud HSM essentially as a DR failover for your keys. You can then plug this into your own applications. You can use it with Amazon services like Redshift and RDS to help you to protect the data with your hardware-based keys. Speaking of keys, another important service is called the Key Management Service, or KMS. This is the ability to have a centralized key store in your AWS account. It plugs into a long list of AWS services and allows you to get to those keys either on premises or from within AWS. Very importantly, all the requests that are made to KMS are logged to CloudTrail, which gives you then the ability to audit and track the use of those keys. Next service I'd like to share with you is called the Certificate Manager. So if you're using SSL or TLS certificates, you can create and manage those within the Certificate Manager, and then you can use those certificates with both ELB and with CloudFront. As you might know, these certificates are used to both protect and to secure websites. They're available from the Certificate Manager at no charge. The service also handles something really important when you start using certificates, and that's the renewal process. The automated renewal helps to avoid the errors that often happen when you have to do manual certificate renewal. Let's talk a little bit about the developer and management-based services that AWS provides. 6 services I'll tell you about today. The first one is called OpsWorks. This helps you to automate your operations. What you do is you define an application architecture and you specify each of the components including the packages that it needs, the software configuration, the storage it needs. You define that architecture and you can then deploy, manage, and monitor that entire application stack on AWS. If you're already using Chef, you can use those Chef recipes and cookbooks within OpsWorks as well. And so you can then model and manage your infrastructure in a visual way through OpsWorks. The next service is called AWS CloudFormation. This one gives developers and administrators a way to create a collection of AWS resources, define them in a single file or in a nested collection of files, and then provision all of those resources in an orderly and predictable fashion. I like to think of this as a declarative cloud-native approach to configuring your IT resources. We give you some sample templates to get started, or you can create your own from scratch. These templates define the resources and the dependencies and the runtime parameters. When you define the template, you don't need to worry about which order the services need to be created or provisioned, or you don't have to think about the subtleties of getting them launched and connected to each other. CloudFormation figures out the dependencies, launches the resources, makes sure that they're properly created, connects them up to each other as needed. The net benefit here is you can do reliable, repeatable provisioning. You define your infrastructure as a template, you launch that as a stack, you enter the parameters, and then every time you do it, you're going to get that same infrastructure set up. Code Deploy lets you manage code deployments to EC2 instances or to servers that are running in your own data center. This works by letting you create a software package, and then you create a file that says, this is the set of steps that will help to deploy the code. You then put that code in either S3 or a GitHub repository. You create a deployment in the code deploy application. You specify the target where you'd like that deployment to occur. And then an agent on the EC2 instances looks for new deployments. When it finds that new deployment, it downloads it from the repository and then installs it according to the instructions you've provided for the install. You can plug this into your existing tool chains, and you can use it to deploy either to AWS or to your on-premises infrastructure. Code commit lets you store code in private repositories. So this is a managed code repository service. So if you're already using Git, the same commands and so forth that you already integrate with Git will integrate with code commit. Behind the scenes, code commit is using S3 to store your code objects, DynamoDB to index, so you get all the durability, availability, and scalability of those services. Even better, all the data that you store is automatically encrypted once you store it in code commit. No intrinsic limits on the type or the size of the files that you can store within code commit. You've probably heard about continuous deployment and/or continuous integration. And the service that we have to help you with putting that to use in your organization is called Code Pipeline. To use Code Pipeline, you define the workflow that you'd like to execute from the moment that the code is checked in. So this could include things like building the software, running unit tests, deploying to a QA environment to run even more tests, deploying to a single production server or region, a final smoke test to make sure everything is running, and then a final deployment to the rest of the production servers and or region. With Code Pipeline, you get the opportunity to automate all the different phases of your deployment lifecycle. When you do this, you should be able to be more consistent. You should have a better level of success with deploying changes because all those changes are always routed through whatever delivery pipeline you define. So that workflow is always going to be followed for every time you check in some new code. If you, like most of our customers, are using third-party tools for testing or deployment, you can plug those into Code Pipeline and use those as part of your overall deployment process. The Application Discovery Service is one of our newest services. This was designed to help our customers plan and deliver on migration projects. The challenge here is that quite often in their legacy systems, they've got a number of running applications. They've been there for quite a while, and it's not quite clear what the applications are, what are the dependencies, what are their network connections, what internal tools they use, what level of resources do they consume. The Discovery Service collects data using a small agent that runs on the on-premises hosts. It then encrypts that data, sends it up to AWS on a secure connection, where the data is once again stored in encrypted form. Once you've got that data, you can explore it with a variety of tools, some from us and some from our partners that are working currently on different visualization and migration tools that are going to help you explore your current set of applications, figure out what's going on, and then ultimately plan your migration as well. Let's move to our next poll, and let me know which developer or management service you would be interested in trying next. Go ahead and share those as they start rolling in. And so far, we have a pretty even distribution. Looks like we've got actually code pipeline and code deploy kind of sticking out, with CloudFormation coming in after that. Keep those poll responses coming for another couple seconds. All right, so looks to final. We've got code deploy and CloudFormation followed by code pipeline. Well, awesome results. Thanks for sharing that. Let's go up a level and talk about analytics. A lot of what we've talked about so far, we're about generating data, collecting data, storing data. Once you've got all that information, you probably want to think about getting value from it by analyzing it. We've got 6 different services I'll tell you about today. MapReduce is a way to work on large amounts of data by dividing it up and running the analysis across a large number of computers working in parallel. Hadoop is an implementation of MapReduce, and our product, Elastic MapReduce, or EMR, is a managed Hadoop that runs on top of EC2. I'm sure you've all heard about big data, and EMR is an essential way to access and work with big data. The way I like to think about this, you take a cluster of machines, you can run your code across this cluster of machines, you can analyze very, very large data sets, and get the final outcome. One very, very common use for this would be processing huge log files from a fleet of web servers or application servers. EMR plugs into a number of different AWS data stores. Many, many different sources generate streaming data, often in relatively small size packets, but large amounts of data. This might be telemetry from Internet of Things devices. It could be log files. It could be information collected on premises as part of a manufacturing facility. The challenge is to get this data up to the cloud for storage and for processing. And so the platform that we have to let you do that is called Kinesis. So Kinesis is the platform for real-time streaming data. Currently 2 aspects of Kinesis. There's a Kinesis Firehose, which is a really easy way to load streaming data into AWS. No administration needed. You can set up Kinesis Firehose and you can do direct to storage. You can route the incoming streaming data to S3 and Redshift. You can get that set up and running in actually a minute. The next aspect of this is called Kinesis Streams. This is a little bit more sophisticated, gives you some more control. With Kinesis Streams, you can build your own custom applications that process or analyze the streaming data. So you've got this real-time stream of data coming in. The extra work you'll do with Kinesis Streams, you'll do a little bit of work to actually create and set the desired level of capacity, a little bit of oversight and watching the metrics to actually scale based on the data volume and the throughput rate that you're seeing. With all this data moving back and forth and from service to service and from on-premises to the cloud and between different analytical services, you often need to design and implement a workflow to supervise the motion of all that data. To do that, we have the AWS Data Pipeline, which is an orchestration system for data-driven workflows. Helps you move data from service to service, basically helping you to model and then schedule all the different operations with optional transformations along the way. The data pipeline plugs into many different AWS services, including S3, RDS, DynamoDB, EMR, and Redshift. You can also connect it up to your on-premises data sources. Again, a newer service, machine learning, designed to help you build smart applications. So this is actually based on the same machine learning technology that we use inside of Amazon. Our internal data science community makes heavy use of this service. It gives you access to machine learning technology without you having to understand how to build out, operate, and scale a machine learning service. Super easy to use. You simply load in your initial data. It then builds a model of the data. And you can then, with that data, you can start to get predictions around new data. You can generate those predictions either from the console when you're experimenting with the service, or you can more likely make API calls to the machine learning APIs. QuickSight is a new tool that's designed to give you access to easy-to-use business intelligence. Connects up to a whole bunch of different AWS data sources. It also lets you query flat files and third-party data sources. Designed to be graphical business intelligence that's both fast and easy to use. When you give it access to your data, it automatically will generate some smart visualizations of that data. Uses an in-memory calculation engine we call Spice. Elasticsearch is a popular open source search and analytics engine that is many customers use for log analytics. So the Amazon Elasticsearch service is a managed service that makes it really easy for you to set up, operate, and scale an Elasticsearch cluster in the cloud. Once you create this cluster, the managed aspect means that all the resources are provisioned, any failed nodes are automatically detected and replaced, and you don't have to do anything to manage or to operate that infrastructure. Next poll question. Let's hear which analytics service you would like to use next. See those answers start flowing in. Fascinating. Okay, looks like machine learning is taking the early lead, followed by Kinesis. So it looks like we must have some forward-thinking folks out there in the audience. Great to see. So I'm seeing machine learning, Kinesis, followed by Elasticsearch. Awesome. Great, thanks for those clicks. Okay, let's wrap up the services with a discussion of our enterprise applications. Amazon Workspaces is a managed virtual desktop solution that runs in the AWS cloud. You can access these virtual desktops via clients that run on Windows and Macs. You can use Zero clients, Chromebooks, iPads, Fire tablets, and Android tablets. When you launch your workspaces, they run inside your own VPC, so you get the ability to secure the workspaces, to control access to them. And within that VPC, because you got full control of networking, you might have a VPN connection back to your on-premises network, so other resources on your in-house network can be accessible to your virtual desktop that's running in the cloud. WorkDocs is an enterprise-level storage and sharing service. It lets you share documents with other people in your organization, and you can share them with whoever you're collaborating with. The collaborators can make comments and leave markup against the document. You can then see that markup, and then WorkDocs will monitor the changes. It will give you access to all the comments. You can then, as the document author, you can iterate and produce successive versions of the document. You can also use WorkDocs for syncing between multiple computers. You can sync between your laptop and your other computers and up to the cloud with your WorkDocs account as well. Workmail is a managed email and calendaring service. It runs with existing desktop and mobile clients. You can use it with Outlook. You can use a web browser. And there's also native iOS and Android email applications. Like other enterprise applications I've talked about, it plugs into your existing directory, and you can use that for management of keys, for data encryption, and you also get to control with Workmail which AWS region where your data is stored. So you end up with a corporate email solution that you don't have to manage the infrastructure, the configuration, or the licensing that's kind of been traditionally part and parcel of enterprise email. AWS IoT, or Internet of Things, is a service that lets you connect devices to the cloud, and those devices can interact with cloud applications and with other devices. So the IoT service handles connecting, communicating, and managing all the devices. These devices use a couple different protocols, including MQTT and HTTP. And IoT is designed to scale to billions of devices and trillions of messages. With all these devices floating around, security is super, super important. So IoT gives you several different security and authentication options. It gives you encryption across all points of connection so that the data doesn't go across connections without proven identity and with encryption. And with IoT, you can build applications that run on the devices and that access various AWS endpoints. And so your devices can actually make calls to the AWS APIs and all the services that I've described previously. You have access to something called a device shadow, which is a persistent virtual image of each device. So the device's latest state is always synced up to the shadow, and you affect a state change on the device by simply changing the state of the shadow, which is then replicated down to the device. If you are building games for the cloud, we have a service called a pair of services actually called Lumberyard and GameLift. So Lumberyard is a cross-platform 3D game engine designed to help you build and deploy what are called AAA games, basically the highest quality games that run on the desktop. And so Lumberyard is the 3D game engine aspect of the service. And then GameLift is the deployment and scaling service for the cloud side end of the game. This also plugs into Twitch, so you can build games that have an audience participation or fan participation component through Twitch. The Lumberyard games have access to the full AWS API. So we've blasted through quite a bit of material here and want to make sure that you have some good starting points in order to actually be able to do something with AWS. The good news, I think, is we have plenty of online resources to help you get started. One thing I'd like to recommend to you is our new Getting Started Resource Center. On that Resource Center, you can find a set of 10-minute tutorials, and these tutorials will help you to get some actual hands-on experience with AWS. Also, please check out the AWS free tier, which gives you access to varying amounts of AWS resources that you can use at no charge and are great to use as part of that Getting Started Resource Center. For our final poll question, give me a sense of what you're going to do next after having listened to our webinar today. Coming on in. Looks like we've got a lot of folks are going to explore a new service. Awesome to hear. Sharing information with colleagues, always appreciated. And then creating AWS accounts as well. Wonderful. Great to hear. Looks like we are just about out of time. I do hope you've enjoyed this really rapid-paced overview of AWS. And thank you so much for coming.